Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Welcome back to this TV learning program. As usual, I'm your chemistry teacher, Teacher Pasco. Today, I will be with senior 2 students. We are continuing with unit number 7, that is mole concept and gas laws. And the next lesson is lesson 8. So far we have already covered 7 lessons. And today's lesson is the limiting reactant or limiting reactants. The objectives of today's lesson are these ones. At the end of this lesson, you should be able to determine the limiting reactant in a given reaction. In a given reaction, we may have 2 reactants or more than 2 reactants, and sometimes can even be 1 reactant. So when we have 1 reactant, we can't say that there is a limiting reactant. But when we have more than 1, it's possible to have what we call a limiting reactant in a reaction. So when you have that type of reaction, you should be able to determine which of the reactants is the limiting reactant. So of course, you should be able also to define what a limiting reactant is. And secondly, you should be able to work out the calculation exercises. We have some exercises, calculation exercises in this lesson. So you should be able to work out some of those exercises, or even all of the exercises involving the calculations of or about the limiting reactants. Before we start our new lesson, I want us to start with a quick revision of what we have discussed in the previous lesson. That was the stoichiometric calculations. So the exercise we have here is magnesium nitrate decomposes when heated to produce magnesium oxide, nitrogen dioxide, and oxygen. Write a balanced equation for this reaction. And B, if 7.4 grams of magnesium nitrate are completely decomposed, determine the mass of each product formed. So let us start with sub-question A. Write a balanced equation for this reaction. If you remember well, we said that to work out these exercises involving stoichiometric calculations, the first and the most important thing to be done is to write a balanced equation. So we are lucky in this question. We have been given a hint, that is the sub-question A. So we start with sub-question A. We write the balanced equation, that is magnesium nitrate in the solid state, which decomposes when heated to produce, it's said, we produce magnesium oxide in the solid state, plus nitrogen dioxide, which is a gas, and oxygen 2, which is a gas. But our equation here is not balanced, so we have to balance it. Balancing this one, we use 2 here, 2, and here we have 4, and 1 mole of oxygen atoms, or oxygen gas. So you can count how many oxygen atoms do we have. 3 times 2, that is 6, times 2, that is 12, and here we have 2 plus, here we have 4 times 2, that is 8, plus 2, that is 10, and here we have 2, making it 12. So the oxygen atoms are balanced. For nitrogen atoms, we have 4 here, and here we have 2 times 2, that is 4. Magnesium, we have 2, and we have 2. So our equation is balanced. And we go to number B. If 7.4 grams of magnesium nitrate are completely decomposed, determine the mass of each product formed. Here, I want to use the method which uses the calculation of number of moles. So we start by finding the number of moles for the substance whose mass has been given, and that is magnesium nitrate. So to find the number of moles for magnesium nitrate, what do? We use mass over molar mass. I hope you remember how we determine the molar mass of compounds. We use mass numbers. The mass numbers that can be determined from the periodic table. So for magnesium, we have 24 grams per mole. For nitrogen, it's 14 grams per mole. And for oxygen, it's 16 grams per mole. And if we calculate the mass number, the molar mass for magnesium nitrate, we have 24 plus nitrogen, that will be 2 times 14 plus 48. And what do we get? 48 is for 3 oxygen atoms, 16, 16, 16. And in that case, what we get is 14. We use your calculators, plus 48, that is 62, times 2, we have 124, plus 24, we have 148. So we have 148 grams per mole. That is the molar mass of magnesium nitrate. And then we have 7.4 grams over 148 grams per mole. And what do we get? We get 7.4 over 148. That is 0.05. 0.05 mole of magnesium nitrate. From the balanced equation, we can see that 2 moles of magnesium nitrate produce 1 mole of magnesium oxide. So we can determine, so it's the same, or we can write 1 mole, 1 mole, okay? So we can determine the number of moles of magnesium oxide, and that will be 0.05 because 2 moles produce 2 moles. It's the same. But here it is the double. So for the number of moles of nitrogen dioxide, we produce 0.05 mole times 2, because it is the double. And that will be 0.1 mole. Okay? 0.1 mole of nitrogen dioxide. And for oxygen, we can see it is the half, a half. So 0.05, we divide by 2. You can use your calculators. We get 0.025. So 0.05 divided by 2, we have 0.025 mole. After getting the number of moles, you can use mass, molar mass times number of moles to find the mass which is produced. So mass of magnesium oxide will be 0.05 times the mass of magnesium oxide is 24 plus 16. This is 40 grams per mole. And what do we get? We get times 40, that is 2 grams. Produce 2 grams. The mass of NO2, it's 0.1 times nitrogen plus, that is 14 plus 32. And here we have 46. And that will be 4.6 grams. And the mass of oxygen, we have 0.025 times, what is the mass of, molar mass of oxygen? It's 32. And 32, we have 0.025 times 32, we have 0.8 grams. So we have all the masses for each product formed. For magnesium, we will have 2 grams, For nitrogen dioxide, we will have 4.6, and for oxygen, we have 0.8. You can verify if what you have got is right. How do we verify that? We remember the law of conservation of mass, law of conservation of matter. If you sum up these values, what you will get will be equal to the total mass that has been decomposed. You get 7.4. Okay, now let's start the new lesson. What is a limiting reactant? A limiting reactant is a substance which is totally consumed in a reaction before the others. And why do we call it the limiting reactant? It's because when it gets used up completely, the reaction stops immediately. The reaction takes place when we have reactants which are combining. But when one of the reactants is totally consumed, then the reaction will stop, even if you have some other reactants which are remaining. You remember the example of a burning candle which is covered by a glass, for example. After some seconds, it gets off. Why? Because the oxygen which was supporting that combustion, when it is used up, then the reaction stops. The combustion reaction stops because one of the reactants which is needed has been used up. It is the same. Let's say that you have your appetite. You still want to eat, but the food is finished. Even your appetite will remain useless. You can't do anything with that. It's still there, but you don't have the other reactant, the food you have to eat. So a reactant which gets used up before other reactants, we call that one a limiting reactant because it immediately stops the reaction. So it limits the reaction. And it also has an impact on the products that will be formed. Why? Because it is the one which will determine the amount of products that will be formed. If you have oxygen that is to react with hydrogen, but you have oxygen in excess and hydrogen in a small amount, the hydrogen is the one which will determine the amount of water to be produced. Because the excess oxygen will be useless as there is no hydrogen to combine with that excess. So I hope you understand what a limiting reactant is. Now let's go to some worked examples involving the calculations. Here we have the first worked example that we are going to solve. How much magnesium sulfide? Magnesium sulfide is this one. You remember the formula. In the sulfide compounds, we have S2 negative ions. S2 negative, S2 negative. So magnesium sulfide is MgS, produced when magnesium reacts with sulfur. So how much magnesium sulfide can be obtained from 2 grams of magnesium and 2 grams of sulfur by the reaction, this reaction? Now, we have to be very careful here. Why? Because you can see that we have the same masses, 2 grams of magnesium and 2 grams of magnesium. But the reason why we have to be very careful here is because these substances do not have the same molar masses. And because of that, if we determine the number of moles, remember when we determine the number of moles, we can also compare the number of particles which are combining. So to determine which reactant is delimiting, or which one will be present in excess, we use number of moles. We don't use molar masses. Sorry, we don't use masses. We just use number of moles. So if you are given masses like this, you have first to convert the masses into number of moles. Because with the number of moles, that is where we can know the number of particles which are reacting. I hope that is very clear. You use number of moles because with the number of moles, it's where we can know the exact number of particles we have that are going to react. And having the number of particles, if I know that one particle of magnesium combines with one particle of magnesium, then I know the number of particles I have here, and the number of particles I have here, I will know which substance is present in excess and which one is present in a small number, and that will be delimiting. So the question here is asking us to determine the limiting reactant or the limiting reactant. How do we do that? As I said, we have to determine the number of moles for each substance, and then we compare them. How do we do that? So we have example number one. Example number one, which one is the limiting reactant or reagent? We find the number of moles of magnesium. Number of moles of magnesium, what do we have? It's mass over molar mass. And the mass over molar mass, do we have the mass? Yes. That's 2 grams. What is the molar mass of magnesium? Use your periodic tables. The molar mass of magnesium is 24 grams per mole. And we use our calculators, that is 2 over 24, we get 0.083. 2 over 24, that is 0.083. 0.083 mole. And we go on to determine the number of moles for the other reactant, that is sulfur. Number of moles for sulfur is equal to mass over molar mass, and that will be 2 grams over 32 grams per mole. What do we get? Again, you use your calculators, and we get 2 over 32. That is 0.0625. 0.0625 mole. Now, let us compare these two values. Number of moles of magnesium, say we have 0.083 mole and 0.0625 mole. Which one is greater than the other? Which one? The first value is bigger than the second, so it's like this. So here it is for magnesium, and here it is for sulfur. So we have more particles of magnesium than sulfur. And remember, from our equation, the balanced equation, it's this one, magnesium reacts with sulfur to produce magnesium sulfide. One particle needs one particle to produce one particle of magnesium sulfide. So for magnesium, if we have this, we would be needing 0.083 mole of sulfur. But what we have is smaller than what we need. So what is the limiting reagent? The limiting reagent is that one which is present in a smaller amount. Okay? And which one is that? It's sulfur. So when these will be combining, sulfur will be used up before magnesium. And we said that the substance which finishes before the others is the one we call the limiting reagent. So in this reaction we have, magnesium is the substance in excess, while sulfur is the substance in a small amount, the limiting reagent. B, we are asked to determine the amount and mass of one of the reactants which remain unreacted. What will remain unreacted? It's magnesium which remains unreacted. And as one particle combines with one, then we have 0.083 minus 0.0625. This gives us the value which will do what? Which will remain unreacted. We have 0.083 minus 0.0625. And we get 0.0205. 0.0205 mole. This is magnesium in excess. The excess doesn't react because we don't have more sulfur to combine with that magnesium. I hope that is very clear. And after finding the number of moles of the magnesium which will remain unreacted, we can use the formula, which is very common, to find the mass of excess magnesium. We use molar mass times N, and we have 24 grams per mole times 0.0205 mole, and what do we get? Times 24, we have 492 grams. So this is the mass of magnesium that will remain unreacted. That will remain unreacted. Very fast, we go to the second example. Here we have 50 kilograms of nitrogen and 10 kilograms of hydrogen are mixed to produce ammonia. Calculate the ammonia formed. Identify the limiting reagent in the production of ammonia in this situation. Remember, to find the amount or the mass of ammonia which is formed, we need to know which is the limiting reagent, the limiting reactant. Without it, because the limiting reagent is the one which determines the amount of product that it will be formed. So let us start with the finding the amount of each reactant. Number of moles of nitrogen. Remember, we use mass over molar mass, and here it will be mass of nitrogen. It is, we have 50 kilograms. 50 kilograms times 1,000 to convert this in grams. So we have 50,000 grams over nitrogen has 28 grams per mole. And for hydrogen, we have 10 kilograms over 2. And what do we get? We use our calculators. We have 50,000 over 28, and that is 1,785.7 mole. And here we have 10,000 over 2, we have 5,000 mole. 5,000 mole means what? You can see for a nitrogen reacting with hydrogen to produce ammonia, how many moles of, we need 1 mole of nitrogen to combine with 3 moles of hydrogen. And so this one should be, the number of moles of hydrogen should be 3 times the number of moles of this. But what do we have? Let's check. 1,785.7 times 3. So what we need to react with this is 5,357. If you multiply this by 3. So we have more hydrogen than nitrogen because we need this amount of nitrogen. So the amount of nitrogen will be the limiting reactant. And the limiting reactant is the one to govern the production of this one. So the amount of nitrogen, ammonia produced, 1 mole produces 2, so it's 1785.7 times 2, we get 1785.7 times 2, we get 3,571.4 mole. And the mass, we know this, it's molar mass times N. You can substitute and work it out. And it is said, identify the limiting reagent in the production of ammonia in that situation, in the reaction we have. Which one is the limiting reagent? We have seen that it is nitrogen, because we needed this amount of nitrogen to combine with this. But what we have is less than what is needed. So this is the limiting reagent, and for the mass, you can substitute 3,571.4 times the molar mass of ammonia is 17. And then you find the mass in grams. Very simple. So you use your calculator to determine the final answer. And here we have your assignment. As usual, we always give you an assignment to try and check your level of understanding. Copper reacts with silver nitrate solution according to the equation. Copper plus silver to produce copper nitrate and silver. If 0.50 mole of copper is added to 1.5 mole of silver nitrate, which is the limiting reagent, and how many moles of silver are formed? You determine the limiting reagent, and you determine the number of moles of the silver which is formed. Number 2, identify the limiting reactant in the reaction of hydrogen and oxygen to form water if 61 grams of oxygen and 8.40 grams of hydrogen are combined. You also determine the amount in grams of excess reactant that remains after the reaction is complete. As usual, let me remind you that if you didn't get enough time to copy that, you take a picture. Thank you very much for your participation. See you next time.